我这次，Hello，好了，声音回来了。刚刚不知道发生什么事情哦，这个不小心按错按钮，把我们的这个麦克风关掉，就声音出来，太奇怪了。好，大家好，欢迎来到我们今天 N 观点的回答 GTC 黄仁勋主题演讲的 Watch Party 哦，这场活动即将开始哦，预计在11点会正式开始哦。那很高兴在线上一起受回答的邀请，再次来跟大家一起来进行这个 Watch Party 的一个活动哦。那今天我们会有我们的赠奖活动哦。我看到有人在 GTC 现场，居然也用手机偷偷连上，要来参加我们的活动，是这样子吗？好，那先在我们荧幕上有我们这一次的赠奖规则哦，其实跟我们上一次是一样的啦。在我们的 RTS 4080黄仁勋亲签版的赠奖规则是这样子，你要答3个问题，这个问题的回答连结已经放在我们的资讯栏里了，你应该有看到吧？他们资讯栏已经有回答连结了那在回答连结里面呢，就是简单讲，就是你要提你的昵称，然后你的联络资料，还有3个问题的答案。那我们会在节目 Watch Party 正式结束的时候，会公布这3个问题的题目是什么，然后你就用最快的速度去回答正确答案，然后送出。然后我们有公布我们的这个表单就是我们这个填答的表单因为我们为了让这个时间是公平的，我们就是公开透明，所以你可以看到你的回答都会出现在我们的 Google 表单里面的这个它的这个 Google 的试算表里面。然后我们就取出回答正确的前3名就可以参加我们的线上轮盘抽奖。线上轮盘抽奖就会抽出1位，然后这位就会恭喜你获得4080黄仁勋的显卡。我不知道现在4080的市价多少啦，但是绝对不便宜，对不对？4080现在市价，我猜应该还是有这个10万吧，应该有吧？这么厉害的显卡好啦，因为我没有整天看这个显卡的价格啦，但是应该不便宜那理论上活动应该在这个几分钟后就会开始了但是呢，因为其实通常办这种活动，这个黄仁勋不一定会准时到啦，他从进场然后到走进讲台开始开讲，可能都还要几分钟啦，所以我猜演讲本身可能会大概落在什么时候呢？我觉得应该11点5分左右可能开始吧大概这样我来看看我能不能线上查4080的价格4080有没有机会查到？没有呢，我看一下原价屋5070一张是卖2万多啦那5080一张卖4万5所以4080现在应该没那么贵了4080应该几万块5090现在最贵，5090还是要10万块好啦，因为这个原价屋上面已经没有4080，所以我不知道现在4080市价是多少那大概这样。有人说没声音吗？现在有声音吗？应该有啦，对不对？应该有声音啦，对不对？我现在放一点背景音乐，大家有听到背景音乐吗？我要把人缩小一点。好啦，不知道大家有没有期待这次黄仁勋的这个演讲那我个人是非常期待的那其实我觉得这个如果你常常听他演讲，大概他会分享哪些东西，应该都清楚但是 毕竟这次是 Computex， 那你觉得 Computex 它会来宣传什么呢？它一定会讲很多跟台湾供应链合作的东西哦。那外界现在在传的这个传说，这次会发表，他们不是前几天都做一个预告广告，这 A new era of PC， A new era。那到底这次会发布什么 PC 呢？那现在外界在传是一个 ARM 的 CPU 的 PC， 废话嘛，我们也知道嘛。然后因为为什么？因为有4家厂商，他们都在 Twitter 上面发布 A new era of PC 是谁的？微软、联发科、ARM 跟辉达，所以我们很容易就可以猜测，这就是一台电脑。这台电脑是装 Windows 作业系统的，它里面的 CPU 是 MediaTek 跟用 ARM 做的，ARM 的架构做的 MediaTek 的 CPU， 然后再加上辉达的 GPU， 我们猜也猜得到啦哈。然后但是我们就来看看外界现在有不少的 rumor， 这 rumor 这台机到底会跑怎么样呢？那我们今天我想监视人就会正式公布这个东西那大家应该要拭目以待，对不对？拭目以待。聊天室有人问 SpaceX 跟特斯拉，可我们今天是回答场次，我就不回答 SpaceX 跟特斯拉的问题了，好不好？好。有人说联发科到底在涨什么？我觉得联发科过去这一阵子它涨的，其实是它外界认为它开始会切入所谓的 AI CPU 的这一块了因为大家知道嘛，以前联发科的 CPU 或者你要把它叫 SOC 也可以啦，主要是在手机端的但是呢，当然联发科绝对是现在全世界数1数2厉害的这个晶片实体公司，所以它要做这个 data center 的 AI CPU 也一定做得出来，对不对？也一定是有一定的厉害程度那在这个 CPU 大家突然发现越来越重要的一个这1个月所以这个我们就看到联发科可能大家就觉得说联发科你会，而且联发科它也有打入那个嘛，联发科它有打入这个 Google 的这个 TPU 的供应链嘛所以我觉得这个应该就是它涨的一个原因啦好，那个辉达他们现在萤幕换了他们说这个你可以看到下面现在这个是那个 YouTube 的中文翻译啦YouTube 的中文翻译他现在是什么等不及啦，这个是他那个背景音乐歌曲的他这个 YouTube 的中文翻译呢，如果等一下如果他翻得很烂的话，我就会把它拿掉，但是如果翻得还不错，我就会把它保留大概就这样子。现在算是开始了，活动算是开始了。现在已经放辉达的这个前导的影片。
Patterns in complexity you could never see. Mirror our cities to keep us safe. And lift us high. Work alongside us. They go where we cannot. Lending us helping hands. And closing the gap between hope and healing so that we breathe easier. And the smallest hearts beat stronger. Tokens are helping us break new ground on a scale never attempted. so we can reach
Star Cloud 1 separation confirmed.
to infinity and beyond.
那现在呢？现在在乌亚大家要走出这个背景
Together,
乐
we
的，
take the next great leap
演讲都是不会
into a bright new future
然后大家看到那个是
built
刚刚看有
for all mankind.
它就是说的 Star Cloud， 它是一个算是新创公司，它已经丢了辉达的 GPU 丢到太空了，所以它其实就是证明了
in Taipei
太空资料中心是可行的。
is
只
where
是
it
当
all
然，你
begins.
最后会把这个东西做得比较成功的，应该还是可能 SpaceX 是比较有机会。
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
大家好 Welcome to GTC Taiwan. So great to see all of you. Very good to be home. I brought my parents home. Where are my parents? Everybody give a round of applause to my mom and dad.
黄仁勋这次是有带他爸爸妈妈，然后2个小孩还有他太太来哦。我上次去他那个动工典礼，他们
And
就都
a
有介绍
round
他
of
们。
applause for our pre-game show superstars, ladies and gentlemen. Look how adorable they are. The superstars of Taiwan. There are so many of you here today. We are broadcasting this right now to 70 other watch parties across Taiwan.
所以我们
70
现在就是
different
他 Watch
conferences are
Party 的
going
其
at the
中一
same
个。我们现在是他 Watch Party 的其中一个。
keynote. We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that NVIDIA builds. But NVIDIA's ecosystem spans all the way upstream to all of our supply chain here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There's so many people to thank. I love my ecosystem here.
其实黄仁勋都非常喜欢介绍他的和台湾的合作伙伴，那我觉得这也是他算是跟合作伙伴建立良好关系的一个很重要的一个方法。
So many. Taiwan's rich ecosystem, the richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago, when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was agentic AI. And today, we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they
我
push
刚
it
刚
back
想
up.
选英文字幕，
Okay,
但
and
是选
so
不到。
if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits.
其实黄仁勋这里讲到的就是这个自从有 AI 之后，这个程式的写作多了非常非常多。那大家都很担心说 AI 会不会取代很多工作，但是如果以程式设计来看的话，明明理论上是 AI 最强的领域，但是像前几天的 All In Package 就说，其实美国的软体设计师的工作职缺反而在上升哦。
Which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is generated by $3 billion worth of salary. That $3 trillion, that $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple. If you can hire a software engineer and you could generate $9 trillion worth of productive work, why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers. This is going to show up in our economy somehow soon. And so the first thing is useful AI has arrived. Now, what does that mean from the industry's perspective? From the industry's perspective, that means that tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units, tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan.
其实 Token Factory 这样的概念就是黄仁勋在过去这1-2年非常强调的一个东西那因为它只有大家买单 Token Factory 这样的概念的时候，所有的云厂商才拼命买辉达的 GPU， 因为辉达 GPU 其实蛮贵的，但是只要这个东西是生财工具，它不是一个只是用来省钱的工具的话，它事实上它可以买的就会越买越多。
First idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator. Behind it is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. Inside, this is an agent. It's an agent application. In the old days, this would be application, this would be code, and this would be operating system. Application, code running inside an application, inside an operating system. Today, it is agent, which consists of a large language model or many sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrates this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do, we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system, okay? And so this is the new computing model, and this is what an agent. It could do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated, and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but Codex does an incredible job as well. Here's another example. This is the input. Create a GIF, NVIDIA green dots on black scatter, form Taiwan 101 building, morph to GTC Taipei 2026.
其实辉达这一次 GTC 会非常强调这个 AI agent 特别是跟这个 Open Cloud 上面的一个协作，他们之前办的很多活动都是跟 Open Cloud 有关那所以我想，其实黄仁勋现在是非常努力要把这个所谓的 AI agent 的东西推动到企业中，因为这会让他们的需求 AI GPU 的需求大幅增加。
New computing pattern. Whereas we used to launch an application, click and type, we now replace that with explaining to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is agentic AI. For 2 years, we've been building towards this, and now it has arrived. Now, one of the big breakthroughs, of course, is tool use. A lot of people have said,
好啦，那我现在要公布我们的第一个提示了，所以我们现在暂时把背景这个音稍微调低我们的第一个提示来了，第一个提示是什么 ？LPU。大家应该知道 LPU 是什么嘛，对不对？但是第一个问题会跟 LPU 有关，那会是什么呢？好，那我们第一个提示就先大家留在这个画面上。
presented to the agent in a way that the agent can use it. This is a big breakthrough. And in fact, what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them CUDA-X libraries. This is NVIDIA's treasure. Today, we're able to now present these CUDA-X libraries to agents who can use it much more effectively than even humans. And so this is a wonderful time for CUDA-X libraries. Let's take a look. 20 years ago, we built CUDA, a single architecture for accelerated computing. We reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science and engineering. CUDA-X libraries are tools for agents. cuLitho for computational lithography. cuOpt for decision optimization. cuDSS for direct sparse solvers. AIQ for deep research across structured and unstructured documents. Arial for AI RAN. Warp for differentiable physics. Parabricks for genomics. At their foundation are algorithms, and they are beautiful.
我讲要快速进到重点也没有用，好吗？这是人家辉达的现场活动，他们现在就是播他们的影片，好吗？所以欣赏他们的影片，欣赏这个影片是想告诉大家，酷达可以做非常非常多事，不是只是大型语言模型而已哦。那当然啦，大型语言模型是现在 AI 最主要的应用。
A round of applause for math. Math is beautiful. The computing pattern of software is going to change. In fact, let's come back to this. This is the agent. It is the ultimate disaggregated and distributed computing model. So many different computers are going to be activated in order to process this agent. The agent consists of model, harness, tools and skills, and a runtime. All of that is running at different places in a data center. You can think of the model as the brain, the harness as the body, the tools that it uses, working in a runtime, think of it as a workshop. So this is a person, a worker, working with tools in a workshop. Of course, this is being done at extraordinarily large scales. And each one of those steps are running in a different part of the computer. And you could see the large language model is thinking, context processing, observing, understanding the environment, reasoning, coming up with a plan, and acting on the plan. Every single time that happens, an entire rack of Grace Blackwell NVLink 72 is activated. It's thinking with the large language model. Whenever it uses a tool, a CPU is used. That tool could be a C compiler. It could be Python. It could be JavaScript. Or it could be accelerated computing. Today's agents are relatively simple users of tools. Tomorrow, they're going to be very sophisticated.
我猜黄仁勋接下来应该要介绍他们的这个 Vera 的 CPU 哦，应该啦，因为这就是他过去这一个月就努力在讲的一个东西嘛，就哇 CPU 独立是一个非常大的一个市场哦。那因为 agentic workflow 里面AI 会呼叫软体嘛。让我们来猜一猜以他现在讲的内容。
So the CUDA-X library, some skills, basically a manual. The AI reads it and go, aha, that's how you use it. The ability to use these libraries by agents are going to be incredible. And so the tools run on CPUs and GPUs and large language models. The security harness runs on CPUs and a security processor called a DPU, NVIDIA's Bluefield. The orchestration of all this runs on a CPU. This is the entire harness, and the CPU is orchestrating all of the work. One of the hardest parts is memory. You could just imagine. The working memory is called KV caching. What to remember, compaction, not just compression, but how to retrieve. Do you retrieve structured data? Do you retrieve unstructured data? What is the ontology, the relationship of all of these different data to itself? That entire processing is incredibly complicated. The memory system of AIs is going to cause the storage system to be completely revolutionized. As you could see, every aspect of this computing model, this computing pattern, this new application called an agent is fundamentally different than the way that applications used to run. A whole bunch of software sitting inside a binary, sitting inside an operating system. This is the reason this disaggregated, this distributed, this heterogeneous computing problem is precisely the reason we built our next generation. Vera Rubin.
耶、我猜对了 ，Vera Rubin 哦，我觉得今天上线的蛮赚的，因为我记得我们第一次要抽这个辉达显卡那一次有2000多个铜哨，今天到现在才500多个铜哨哦，因为上班日吧哦，所以大家中奖的几率蛮高的哦。
It has GPUs, Vera Rubin NVLink 72. It is orchestrated by Vera CPUs that I'm going to tell you more about. The storage systems, revolutionary. Vera, along with CX9, our software stack called Doka, the security processor that's inside so that everything is encrypted at rest, in motion, as well as in use. Everything across this is secure because the AI model is so precious. This is the reason why this entire system obeys confidential computing. Each one of these systems would be a complete revolution in itself. Vera Rubin is the most ambitious endeavor in the history of our company. The whole company worked on Vera Rubin across all 40,000 engineers, not to mention all of you. All of you participated in the creation of this entire system. Vera Rubin is really a miracle, and it's not just one chip, it is so many. Well, it's even beyond that. A long time ago, NVIDIA used to be a GPU company. But over the years, we've evolved to become a systems company. You're looking here now for the most complex system, most complex and ground-up system ever designed. But ultimately, our customers, our partners, don't want to buy computers. They want to build AI factories, which is the reason why NVIDIA has really started to transform ourselves yet again. You could see so much of our technology is now at the entire infrastructure scale. Our partners are at infrastructure scale. Power generators, cooling systems, the grid providers. So many industrial companies are now part of our ecosystem because ultimately we're trying to build an entire stack just like GPUs, just like when we were building Grace Blackwell NVLink 72, just like now, we are building a full stack system so that our customers could build amazing AI infrastructure. Let's take a look.
The world is racing to build AI factories, the largest infrastructure build-out in human history. AI factories are incredibly complex. Every layer, chip, rack, network, power, cooling, grid, must be designed together from end to end because compute is revenues. NVIDIA DSX is the blueprint, a reference design for building and operating AI factories at maximum efficiency and profitability. It starts with DSX Sim. With the DSX Sim Omniverse blueprint, partners design and validate an NVIDIA Vera Rubin AI factory before a single rack lands. They plan the layout, simulate the power and cooling, design the network, validate every integration, test every change in the digital twin. The factory powers on. DSX OS takes over and provisions, operates, monitors, and remediates the infrastructure, turning the installed systems into trusted, multi-tenant, resilient, AI-ready capacity. Today's AI factories over-provision power by up to 40%. DSX Max LPS lets operators safely deploy more GPUs inside the same power budget, adding billions in annual revenue. Breakthrough hot liquid cooling at 45 degrees Celsius uses less water and energy. More power going to revenue-generating compute. Incredible. Dynamic power allocation steers power from rack to rack, recovering stranded watts, sending them where work is happening. In-rack power smoothing flattens peak current spikes and power surges. Throughout the factory, teams of AI agents work with DSX Max LPS, continuously coordinating to balance cooling and power to meet workload demand. DSX AI factories are flexible energy assets that operate cooperatively with the grid. DSX Flex reads real-time grid signals and dynamically adjusts factory power when the grid needs relief. 100 gigawatts of AI factories will come online before the end of the decade. NVIDIA DSX AI factories run at highest efficiency, produce the lowest cost tokens, and make the grid stronger.
I've shown you ecosystem slides of the past, where NVIDIA's computing layers and software and
好啦，我们时间差不多到了，要给大家第二个提示。第二个提示是什么呢 ？model， 小米 model， 模特不是模特啊，模型了。那小米模型呢？小米模型 model，OK、啊，这是我们今天的第二个题目的名字的提示 ，OK。
We're helping customers build these AI factories, these AI infrastructure that is so immensely complex. Each one of these at 1 gigawatt level started at $30 billion. It is at $50-60 billion, and soon it will be $80-100 billion per gigawatt. $100 billion into an AI factory. It must work the first time, and it must work right away. The cost of capital is incredible. The complexity is incredible. So as you see, we used to design a chip inside a computer. And then we simulated a system inside a computer. Today, you saw just now, everything was built in Omniverse. I've been working with Omniverse with all of you for a long time. This was the dream come true, so that we can build these gigantic systems as large as the world wants to build inside a digital framework, inside a digital simulator, in a digital world, long before we build the first break ground and put our money to work. So this is our ecosystem. We call it DSX. RTX is for our GPU, DGX is for our systems, and now DSX, basically infrastructure. Because of the work that we do here across this entire stack, including our systems and software, it's the reason why we can work with small companies and enable them to be world-class AI clouds. Every one of these I'm about to show you are small companies just recently. And now CoreWeave is worth $50, $60, $70 billion and growing incredibly fast. Recently, we worked with Nebius, and again, they're growing incredibly fast. Each one of these clouds have incredible customers. Cursor, the software coding company, Black Mountain Labs, Image Generation, World Labs, World Foundation Model, Revolut, the leading financial services AI company, and Shopify. Here's another one. This is Nscale, and their customers are British Telecom, Google. Google is using one of our AI clouds, Thinking Machines, a Frontier Labs company. We're super exciting. Here's Naver Cloud in Korea, Bank of Korea, Hyundai, so many incredible companies. Here's one in India, Yoda, incredible companies. Here's one based in Singapore, building in Australia, Together AI, AI Singapore. This is one in Indonesia. Each one of these companies are serving regional as well as global customers. AI is going to run everywhere. Every company will be powered by it. Every region will build it. Indosat here in Indonesia. Here in Taiwan, GMI. Here in Taiwan, GMI. It's okay to clap.
拍手，怕破啊。
So, incredible companies, incredible opportunities.
好啦，那一边听这个演讲的时候，不要忘记我们今天有抽奖活动，我们今天有赠奖活动哦。RTX 4080黄仁勋签名版哦，我们会问3个问题哦，前2个问题的提示都已经给大家了，所以我们在这个直播结束 Watch Party 结束后，我们会公布3个问题，那前3名答对的就可以参加抽奖哦。
Cloud. However, The AI cloud is so complex now. This is the software version. This is the computer science version. The money version, the asset version is what I showed you earlier. It's a giant factory. Having this ability alone is not enough, which is the reason why NVIDIA has become an AI infrastructure company. Now, doing this well and becoming incredibly good at helping customers build AI factories and deploying AI factories is incredibly important. And the reason for that is this: compute is revenue now. Compute is profit. The absence of revenues and profit is loss. And so it's really important to realize that this is an example of an AI infrastructure coming online. It could be coming online quickly. It could take a while. Its throughput could be high. It could be low. Its resilience and reliability could be good or bad. And its lifetime of usefulness could be long or short. Because this represents 50, 60, going to $100 billion. This curve matters greatly, which is the reason why NVIDIA is such a great partner. Working with us because of our fully integrated capability, we didn't just come up with a PowerPoint slide. We created the entire infrastructure. We connected everything together. We built out billions and billions of it ourselves to make sure that everything works well. As a result of that, our time to first token, our time to first inference, our time to training turned on is much faster. Second, because our throughput per watt, our tokens per watt is utterly world-class. And the reason for that is because we integrate everything, we design everything from the ground up, we simulate the entire system, and we use extreme co-design. Just like I showed you just now with the Vera Rubin rack, everything was designed in order to deliver on this incredible throughput. If your data center, if your factory has 1 gigawatt, it will not have more. 1 gigawatt means 1 gigawatt. That's all the power generation you could do. If you have 1 gigawatt of power, then throughput per watt is revenues, because every token is profitable. Every token is revenues. This is the future. Compute is revenues. Performance per watt is your revenues. Choosing the wrong architecture just because the chips are cheaper doesn't translate, doesn't make sense. You need to make sure that your revenues per watt, the more you buy, the more you make.
所以这个就是黄仁勋近期他很努力在讲的东西，就是如果你每电力产生的 token 数，因为 token 可以卖钱，辉达的系统是可以帮你赚最多钱的，所以他就说你不要看什么 TPU 啦，看 Training 他们都比较便宜，对不对？但是呢，如果你有一样的电量，然后我可以产出最多的 token， 你最后可以赚更多钱。然后那他其实黄仁勋一直说我们的股价被低估了，那市场都看衰我们了，所以他现在一定要卖这个概念卖给大家，因为你如果相信这个概念，你就会相信辉达的业务的长远性会更稳固。
The lifetime of these systems, the software is changing all the time. 4 years ago, which is in the time of Hopper, AI has completely changed. 6 years ago, this is the time frame of Ampere. AI has completely changed. We started out talking about CNNs. Here we are, then we talked about transformers, and then we talked about mixture of experts. Now we're talking about agentic systems. Every single generation, every single few months, the software industry is coming up with new technology. If your architecture is not flexible, if your ecosystem is not rich, then this curve cannot be long. You cannot predict how long your system can last. I can. NVIDIA systems is all over the world. Software developers start with NVIDIA CUDA. And by definition, therefore, the life, the ecosystem, the useful asset is going to be much longer. The difference is essentially cost. You could think of it as revenues, but the other side of revenues is cost. If the life of the asset is long, the TCO is low. This is the difference. This is what it looks like when compute. The more you buy, the more you make. Now, all of you are experiencing this with me. Isn't that right? All of your demand, your factories are working so hard, your people are working so hard all across Taiwan because everybody wants to make money. They realize that AI, useful AI is here. Profitable AI is here. Compute demand is incredibly high, and compute demand is the constraint. And so let's go work super, super hard and help the world stand up AI factories everywhere. This is why it's so important. I'm so happy. Here I am standing in front of you. Vera Rubin is in full production. Vera Rubin is in full production. The supply chain we created for Vera Rubin is twice as large as Grace Blackwell. It's incredible. And what used to take 2 hours to assemble one Grace Blackwell rack now only takes 5 minutes. So not only is the capacity higher, the throughput is a lot faster, and we need it all to support the demand. This ecosystem is extraordinary. Millions of square feet has been put online to support Grace Blackwell and preparing now, ramping up now, Vera Rubin. I want to thank all of you. Vera Rubin is now in full production. Thank you. Let's take a look.
Large language models generate answers. Now AI agents can do work. But processing agentic AI is a whole different kind of problem. Agents observe, reason, plan, use tools. They manage massive context, juggling working memory and long-term memory. They spin up sub-agents, specialists on demand. NVIDIA Vera Rubin is a multi-rack pod-scale system built to process agentic AI and is now in full production. The manufacturing, automation, and orchestration across the supply chain, a miracle to witness. Our journey started when we launched the first AI supercomputer, NVIDIA DGX-1. Over the next decade, we pushed every chip and system to the limit, from Pascal and the first NVLink to Grace Blackwell, the first rack-scale AI supercomputer. And now, Vera Rubin, the first multi-rack pod-scale supercomputer, built for the agentic age. It starts at TSMC. The 7 new chips that make up Vera Rubin take shape.
我先讲一下，原本预计45分会给第3个提示，但是我现在可能会稍微 delay 一下，因为我很期待一些可能在这一次这个 GTC Keynote 会宣布的一些新东西，所以如果我们最后演讲最后宣布一些新东西，我们会用那个新东西来出题哦。那我有预备的第3个题目，但是我现在想要等一下，所以如果等一下有新东西出来的时候，我们就赶快把第3题的题目改，让大家用新东西，好吧？所以最后一个提示，现在看起来45分我不会给，可能50分或55分左右可能会给大家第3个题目的提示，好不好？
All made in place, with no cables for resiliency at AI factory scale. 18 compute trays, 9 hot swappable NVLink switch trays, new high-efficiency manifolds, liquid-cooled bus bars, carrying over 5,000 amps, the equivalent of 20 electric cars at full acceleration. Together, 1.3 million components form this third-generation MGX rack design. Congratulations to Microsoft for their operational Vera Rubin NVL72 engineering rack. Congratulations to Dell and CoreWeave as well for standing up their Vera Rubin NVL72 engineering rack. Then, the Vera CPU rack, 256 CPUs in a single liquid-cooled rack, orchestrating the models, shuffling memory, launching tools. At Foxconn and Quanta, Grok 3 LPX takes shape. 256 Grok 3 LPUs across 16 trays, 40 petabytes per second of SRAM bandwidth for ultra-low latency. While NVL72 generates tokens at the highest throughput, Grok LPX generates them at the lowest latency. Vera Bluefield 4 STX, where AI keeps its memory. Storage processing accelerated by Bluefield 4, connecting memory, storage, and in-silicon security. And NVIDIA Spectrum X Ethernet Photonics, the world's first Ethernet switch with 200 gigabit co-packaged optics, TSMC's COUPE process, chip-scale packaging, and ultra-high-powered laser dyes on indium phosphide. Vera Rubin, 5 connected rack-scale systems, a supercomputer for AI agents, 150 supply chain partners across Taiwan, millions of square feet of factory floor, hundreds of sites, chips, packages, systems, and data centers pushed to the limits of size, power, and scale. This is what we call extreme co-design. We did this with Taiwan. Together, we reinvented computing for the age of AI. Taiwan was with us at the beginning, and here today, as we bring Vera Rubin to the world. Thank you, Taiwan.
Ladies and gentlemen, Vera Rubin. Vera Rubin was not just built for AI. Vera Rubin was not built just to run AI. Vera Rubin was built to run agents. This is an agentic system. Imagine the complexity, which is the reason why agents is the last computer science breakthrough. It has taken this many years for agents to realize its potential and become useful. It stands to reason that the computer that runs it is the most advanced in the world. This is Vera Rubin. Let's take a look. Can we bring out Vera Rubin, please? And Janine, do we have the racks, the systems? It looks heavy.
黄仁勋他说他要 rack system， 是说他想要让一台一台的这个放在机架上面的这个可能是2U 或4U 的机器的 size 啦。哦。
About a lot more of this. Today, we have so much to talk to you about. This is Vera CPU rack, 256 CPUs, all liquid cooled. Let me tell you about Vera in just a moment. This is the Vera Bluefield storage processing system and also security system. And of course, this is our Mellanox networking, the world's first CPO. This is Vera Rubin. Incredible technology all coming together. Now, when we built Hopper, as you know, for pre-training. Pre-training was the most important application, the most important workload we were working on at the time. Then when we worked on Grace Blackwell, everybody said, Jensen, NVIDIA is really good at pre-training. Inference is so easy. Do you remember that? People used to say, inference is so easy. We could do that too. But as you know, inference equals money. And the models, MOEs, are so complicated. And to do it at incredibly high response time, fast interactivity, and high throughput at the same time is incredibly hard, which is the reason why we created NVLink 70.
其实在这里我把音量调小一点，我讲一下我的感想我觉得辉达或黄仁勋他们最早在讲说他要整个 reinvent 整个 data center 的 computing， 大概是在2022年左右应该就开始讲了吧。就是说他说下一代 AI 或 GPU 运算的架构资料中心会长得完全不一样。老实讲一开始我 没有那么相信它会那么成功哦。但是我真的很佩服他们在过去这几年就是一步一步的把这些东西都打造出来，然后从这个原本的只是一台机器有8个 GPU 的这种所谓的 HGX 的伺服器，慢慢变成 NVL72 的机柜系统，慢慢从一个机柜变成多个机柜，慢慢从有 NVL72 的机柜之后，现在还有 CPU 的机柜。有 CPU 的机柜以外，还有 LPX 的机柜，有 LPX 的机柜以外，还有这个 storage 的机柜哦。我觉得它真的就是开始把这个所以下一代的以 GPU 为核中心的那个的这家中心打造出来了哦。那我觉得这真的是你问我在5年前，我听到他这样讲，我会不会相信？我绝对不会相信这个可以成功到这种程度哦。所以辉达真的是很厉害的一家公司哦。
2 Vera CPUs, 4 CX9, incredible amounts of software. This is our new LPX, LPU30, the Grok system, designed for very low latency inference. The throughput is delivered by Vera Rubin and extended with NVLink 72. If you want to extend that even further, you can have Grok LPUs. Here, we have the Vera Rubin NVLink, the switch tray. This is the switches in the middle, and this is revolutionary. Because of Vera Rubin's, because of NVLink 72 and the NVLink switches that we created and invented. And this is our Ethernet switches for scale out. What's amazing is we introduced these two systems for Grace Blackwell. These two systems were created for Grace Blackwell. And today, NVIDIA is the largest networking company in the world. I'm so proud of the networking team. This is such an incredible enabler for everything that we do. I'm going to now talk to you about the next major industry we're going to be part of. Thank you. Janine? Thank you. Zaijian. I think there are 2,000 people back there pulling that. Okay, let's talk about CPUs. Vera CPUs. CPUs built for the age of AI. All of the CPUs until now were created for people. We were the users. We were the users. We were the renters. The way we use CPUs, we live in a world counted by seconds. The way we rent CPUs in the cloud, each one of them, more CPU cores you have, the more you can rent. The economics of the use case of the old CPU and the economics of the old CPU, fundamentally different than agents. Agents are impatient. They don't live in a world that is in seconds. They live in a world that's in nanoseconds. When it uses a tool, it wants the response time to be as fast as possible. When it accesses database, it has to come back as soon as possible. Every moment that the agent is waiting keeps it from going to the next step, the next step, the next step. It is vital that we make the CPUs as low latency as possible, as interactive as possible. So we created Vera CPU for the age of AI. Now, inside our system, it's used for 3 different ways. The first way, of course, is Vera Rubin for thinking. And inside the Vera Rubin rack,
其实它这个阶段其实大概就是要介绍 Vera CPU 作为一个独立 rack 的一个存在价值啦，它的独立的业务。因为之前他有说嘛，光这个 CPU 作为 agentic work 的未来的整个市场价值可能就$2000亿哦，所以他现在就是跟大家解释说 Vera Rubin 它以前这个 CPU 只是用来调度 GPU 的运算搬运资料的，可是我猜他接下来要讲的就是哇，这个 Vera Rubin 这个 Vera 这个 CPU 它未来可以做的事情更多哦，它会有个独立的机架，我觉得它接下来要介绍这个 Vera 独立的 机架的部分。
The Vera compute is used for the harness, the orchestration of the AI models, tool use, accessing the database. And the data servers are right here, Vera Bluefield, the fastest storage servers, the fastest storage system the world has ever made. And the reason why this is so vital is because agents are accessing memory so incredibly fast. These systems, the storage server and the CPUs, are now the critical path of the most expensive part of the data center. This is the most expensive for a good reason. The economics of the AI factory is tokens. And the tokens are created here. And so, of course, you want to manufacture and generate as many tokens as possible. This is where you put all of your economics. And this has to not be in the way. And so Vera CPU has great pressure on the CPU architecture, which is the reason why we built a brand new architecture from the ground up. A CPU the world has never seen before. We call it Vera. This is CPU for agents. All the CPUs of the past, we built for humans. This CPU is built for agents. Well, there are 4 things to keep in mind.
第3题的提示我还没有给，因为我期待他这个演讲的最后会有一个新的东西的发布了那可能跟台湾供应链蛮有关系的所以我想把第3题的 quota 留给那个东西。那如果到时候他没有讲那个东西，那我就会出别的题目所以我们现在就第3个题目，我们就等一下，好不好？
Single-threaded performance, which is the reason why the IPC, the instructions per clock of Vera, is so high. It's the highest in the world. 10 instructions fetched, decoded, and executed per clock. Number 1. Number 2, the bandwidth necessary to move data in and out for the CPU has to be utterly world-class. The second thing is bandwidth per core. The third is just bandwidth, period. We're moving, remember, I said earlier, agentic systems is fundamentally disaggregated and distributed. Disaggregated and distributed. When computing is disaggregated and distributed, networking becomes the problem. Therefore, we have to move the data around as fast as possible between the CPU cores and between the CPU and the storage, the CPU and the GPU. The bandwidth.
所以接下来他应该要讲的是 NVLink 跟 NVLink 跟这个 Spectrum 吧，我猜啦 Spectrum X.
Literally at reticle limits with a fabric that connects all of the CPU cores that is speed of light. 3.6 terabytes per second. No chiplet tax, no chip boundary crossings, because we need to have everything, because the CPU cores are talking to each other with extremely high bandwidth. They're not rented core per core per core, they're all working together.
我看到聊天室有人问要如何参加正讲活动，我现在把正讲活动的规则打在这个的图片放在画面上，你可以看一下
To have DDR5 with 1.2 terabytes per second. 2 to 3 times the bandwidth of the highest performance CPUs on the outside, 3 times the bandwidth on the inside. The bandwidth per core and the bandwidth period is world-class. Now remember, I showed you earlier, the number of CPU cores, the number of CPUs is going to be quite high. And the reason for that is very simple. We created CPUs for humans in the past. And humans, there are only 1 billion of us. There will be billions of agents. And these agents are going to be using the CPUs with very little patience because the cost of the GPU they sit next to is too high. And therefore, too valuable, too precious. Therefore, these CPUs are going to be both performant, but they also have to be extremely energy efficient so that we can cram as much CPU as we can into the factory without taking away power from the token generation, which we know is how we make money. These 4 properties, instructions per clock or single-threaded performance, bandwidth per core, the total bandwidth around the chip and inside the chip, and energy efficiency defines Vera. It is absolutely world-class. When you compare it to the highest performance x86, it is just off the charts. When you compare it in real single-threaded
X86 被拿出来编了哦。X86 被拿出来编了哦，这个 AMD 跟 Intel 哦，你们的 CPU 不行哦。
deliver 10%. But this kind of performance speed up is just unheard of. This is NVIDIA Vera. What do you think? Let's take a look.
Agentic AI changes the role of the CPU. The CPU is now the conductor, and the GPU is the orchestra. Traditional CPUs were built for a different era, maximizing cores per socket. Slice them up, virtualize, rent by the hour. In the age of agents, the CPU is now a bottleneck to GPU utilization, directly affecting token throughput, latency, and user experience. NVIDIA Vera is the CPU built for the agentic loop, combining NVIDIA's custom data center CPU core with the scalable coherency fabric for the right balance of performance cores and bandwidth to maximize AI factory output. At the heart of Vera is the NVIDIA Olympus core, built for modern data center workloads, branch-heavy Python runtimes, tool calls, and sandbox code execution. Each core is tuned for throughput, a neural branch predictor evaluating 2 taken branches per cycle. A 10-wide decode engine brings in more work each cycle. A large out-of-order engine keeps instructions moving. Advanced prefetchers with a novel graph engine anticipating the next data path. But fast cores only matter when data arrives correctly and on time. Vera is the first CPU to use LPDDR5X memory, while correcting multiple errors simultaneously without compromising bandwidth. Vera achieves 40% lower peak memory latency versus x86, keeping cores fed on time through retrieval, analytics, and sandbox execution. NVIDIA's second-generation scalable coherency fabric unifies all 88 Olympus cores on a monolithic mesh with separate dies for memory and I/O. Cores are not split across chiplets, enabling 50% faster core-to-core communication than traditional CPUs. And memory-coherent NVLink chip-to-chip connects GPUs directly to the fabric. Beyond GPUs, NVLink chip-to-chip can scale Vera up to multiple sockets, enabling massive bandwidth between CPUs. Vera delivers 1.8 times the agentic sandbox performance of x86 CPUs. Standalone Vera racks run agent sandboxes, tools, code, and data pipelines. Tightly coupled to Rubin GPUs, Vera keeps accelerated workflows moving. NVIDIA Vera Bluefield 4 STX powers context memory and AI storage. Compute, networking, storage. Vera is the CPU for the age of agents.
This is going to be our new major growth driver. The reviews are already coming out, and it's pretty good. That's pretty good stuff. Now remember, Grace and Vera are also the most highly qualified CPUs in the world of AI, because every single data center, every single cloud, every single enterprise, every company that works with NVIDIA on AI has already qualified Grace. The entire software stack has already been optimized for Grace. Every company will be qualifying Vera. Vera will be the most optimized agentic CPU in the world, simply because it's going to go with Vera Rubin. Simply because we made the big hard switch. In fact, during Grace Blackwell transition, the biggest risk was going from external CPU x86 into Grace Blackwell. That transition was extremely dangerous, but we did it with incredible execution. Now Grace is literally synonymous with Grace Blackwell. When people say Blackwell, they say Grace Blackwell, because it is utterly now everywhere. Every company's software stack has been optimized for it. Everybody's security stack has been optimized for it. And now here comes Vera. I'm super excited about that. Now look at some of the performance numbers. Speedups is one thing. It is extremely hard to speed up SQL. SQL, the most famous domain-specific language, DSL, that has ever been created. Before SQL, before CUDA, there was SQL. Before OpenGL, there was SQL, invented by IBM. Today, it is the structured database engine of the planet. Everybody uses SQL. This is SQL running 3 times faster. Not 10% faster, not 25% faster, 10 times, 3 times faster. Incredible. This is real-time. The next one is real-time stream processing. Remember, your AI is going to be not just reading documents. Your AI is going to be watching for telemetry, especially inside a factory, inside a stock exchange. You're going to be looking for telemetry continuously. The burst of data that's coming in goes into a CPU. This is Vera CPU running real-time stream processing for New York Stock Exchange. Lynn Martin, the president of New York Stock Exchange, has been so gracious to partner with us. This system is run all over the world in real-time stream processing. Vera CPU 6 times, all because of the bandwidth, the single threaded instruction execution, the bandwidth inside between the cores, the bandwidth outside. Vera is completely revolutionary. That's Vera. X factors is something you talk about when you're talking about GPUs. It is quite rare that somebody talks about X factors on real workload that is associated with CPUs. So I'm so proud of the team. You guys did such a great job. We have an extraordinary roadmap coming. But what's really exciting is almost everybody is supporting Vera. They're as excited as we are. This is Vera opening up.
提醒一下，我们今天的这个问答活动哦，这 Q&A 活动的前2个问题的提示。第一个问题的提示是这个 LPU 啊，第2个问题的提示是 model 啊，都跟辉达有关系的。
We are building millions and millions of errors, and to go to market with us. Taiwan's ODMs and computer makers, all the OEMs, and you could see the early adopters. The early adopters are the agentic companies. This is the beginning of a new market, a market that never existed before. It's not going to take away from the old markets, but this is a new market. CPU for agents. And this will...
黄仁勋今天那个 Vera 介绍真的很久，他今天这个 Vera 介绍20-30分钟哦，有哦，这个大家觉得为什么？是因为一般认为Vera CPU 的营业额没有被定价到辉达现在的股价了。那外界一般的看法是这个样子。
Important slide, really. This is the takeaway. The takeaway here is that this is the application pattern. This is the computing pattern of the next decade. Agents, harnesses, orchestrating large language models. Every company will run it. Every company will be an agent company. Every company will have agents running inside. Every company will see that agents will need its own operating system. Every company is asking us, how do we run agents safely? How do we build agents for our own workloads? And so we have the NVIDIA Agent Toolkit for enterprise AI. You've seen me build this in plain sight. Almost everything that NVIDIA does, as you know, at every GTC, if you go back and look at my GTC 5 years ago or 10 years ago, you will see today. This you've seen me talking about for several years now because we've been building for this moment. There are 4 things that companies need in order to build agents as a service or build agents to operate. The first thing you need is you need models. Of course, large language models. The smarter, the better. The cheaper, the better. The faster, the better. The second is you need a harness to orchestrate the whole thing. The third, these models want to use tools, and these tools come with its skills. And I showed you CUDA-X libraries. Those are going to be amazing tools for the agents in the future. And then lastly, you need a runtime. You need the operating system that holds it all together. This is the NVIDIA toolkit for agents. It includes models that you can modify, NVIDIA's world-class open models, and I'm going to show you more. You can run agents from anybody. You could run Cloud Code, incredible agent, Codex, incredible agent. You could run it inside this harness called OpenShell, which will be highly secure for your inside the enterprise. The shell protects the agent, keeps it grounded in security policies. Privacy is protected. Its rights and privileges are given. Its identity is protected. And so this OpenShell is being adopted all over the world. NVIDIA OpenShell is open source. You're going to see so many companies adopt it. Red Hat, Canonical, Microsoft. It's going to be adopted everywhere. This is the runtime. And this runtime is fully optimized for the NVIDIA AI platform, which is everywhere. So you can run OpenShell in any cloud, on-prem, and even on device. So you have now tools and libraries that they can use. You have models that you can modify or use as is, or you have agents. This would be OpenClaw, Hermes, another incredible harness. These agentic harnesses can now run on-prem or for you anywhere, okay? So 4 things, and this represents the operating system of the modern enterprise. Now, how do we use this? One of my favorite use cases of agents is chip designers. It is the single most important thing that NVIDIA does. And so, of course, we have to partner with Cadence to build super agent, a chip design super agent. It is orchestrated by Codex or Cloud Code. It has RTL and architecture diagrams or schematics or specifications as input and whatever you need to fix. And together we created some super agents that are optimized for the NVIDIA runtime with Nemotron. And let's take a look. It's really incredible.
Cadence and NVIDIA are partnering to build chip design agents. Hundreds of thousands of NVIDIA chips come together to make the AI factories that power the world's frontier AI models. Designing these chips and the systems they run in is one of the hardest engineering challenges. Trillions of transistors, 3-dimensional circuits, microscopic scale, every gate, every wire, synchronized to picoseconds, must work in perfect harmony, with no margin for error. Physical prototypes are too slow and too costly. So engineers work in the digital realm. Each chip begins as a set of architectural specifications, then translated into RTL, the language of chip design. RTL must be verified in simulation. A single bug can delay a chip by months. At NVIDIA, thousands of engineers, billions of compute hours per year, millions of tests, written, run, and debugged, a cycle that takes teams weeks. To compress this cycle, Cadence and NVIDIA built a design verification agent. Codex orchestrates the process. Cadence ChipStack launches the RTL verification loop, powered by Nemotron and secured by NVIDIA OpenShell. calling on expert sub-agents in RTL generation, test bench creation, regression testing, and debug. The system drives itself. The chip stack agents run hundreds of simulations with Cadence Xcelium, formal verification with Jasper. Design flaws, revealed. Bugs in the code, fixed. What once took weeks, now takes hours. Verification cycles over 40 times faster. Together, NVIDIA and Cadence are reinventing chip design with AI agents.
From weeks to hours. From weeks to hours. From weeks to hours. NVIDIA has thousands of chip designers. We are going to hire hundreds of thousands of Cadence super agents that work with us so that we can accelerate our company, so that we can be even more ambitious, create even more amazing things, run even faster. You saw earlier that the toolkit with models, harness, tools. The tools in this case are Cadence simulators and verifiers, formal verification systems. It is the reason why we're working with Cadence so hard to accelerate all of their tools on CUDA, because the agents are impatient. The agents want the answer immediately. And so models, harnesses, accelerated CUDA, accelerated libraries and tools, and then the runtime. What you saw just now is all of that coming together. Now, one of the things that it starts with is a great model that Cadence could modify and tune to be expert at the Cadence workflow, at the Cadence expertise, so that they could create super agents that are proprietary to Cadence with their proprietary knowledge. They have to start with an excellent model. We call it Nemotron. NVIDIA is dedicated to build open models for the world so that all of you, all of us, could create our own agents. Today, we're announcing the Nemotron 3 Ultra. Yep, our next open model. And it is smart. The Nemotron models not only give you the model, we give you all the data that we use to train the model. And because we have a coalition of incredible partners, you can see all of our partners down here, we work together, contribute data to each other. Nemotron is trained on one of the largest suites of long-running reasoning models, long-running tool, task-solving, tool-using data sets in the world because of all of our great partnerships. All of this from the model, the training script, and the data made completely available.
我讲一下这个 Nemotron 3这一个模型哦。事实上，它在现在的开源模型里面算是，特别是欧美这边算是这个应该，我不知道是不是最厉害，但是是非常前面的哦。那台湾不是很多人都批评说，为什么我们台湾没有自己的主权模型呢？当然啦，我觉得以台湾政府的拥有的资源跟算力跟资料，真的也很难自己做模型啦。但是我真的觉得，像如果是3年前，你可能会用拉玛来打造一个这个有台湾资料跟台湾做一些相关的 guardrail 的一个模型嘛。那我觉得以现在来讲，或许 Nemotron 可以是台湾政府去考虑使用的一个基础模型，然后来做一个 fine tune， 做出一个台湾的主权的模型啊。
30% lower cost to run in total flops and total inference time than even the most cost-effective in the world. We're comparing against the world's best open models. Frontier Smart, 5 times faster, 30% cheaper, completely open. We're completely dedicated to this. This is now Nemotron 3. We're currently working on Nemotron 4. So this entire toolkit, from models, harnesses, tools and skills, and runtimes, is the reason why every enterprise company in the world has the ability now to create their own agents, just like Cadence did with their super agents. And we're working with so many companies, Cadence and CrowdStrike and Dassault and Palantir, SAP and ServiceNow. People were always said, Jensen, the agents are going to disrupt these markets. I said completely opposite, and you can now see it. Agents is going to create the largest opportunity ever for my partners and friends. And we have the the NVIDIA Agentic Toolkit for enterprise AI to help them. So, there you go. First, Vera Rubin in full production. 2, Vera CPU built for a new generation for agents. And 3, NVIDIA's enterprise AI toolkits so that every enterprise and every enterprise software company can build agents.
哇，期待的章节来了哦！台湾厂商最期待的一个部分应该要来了哦。看看我们第3个题目能不能从这边出哦。
Many of my friends and partners here in Taiwan, your companies started here. This is, in a lot of ways, the beginning of the modern computer industry, 40 years now. NVIDIA is 33 years old. The PC industry was already starting to get to Windows 1 and Windows 2 and Apple 1 and Apple 2. And by the time that we came along, Windows 3.1 was the PC. And as you know, Windows 95 made PC personal. It took PC from enterprises, companies, and made it into a consumer electronics device. Everybody should have one, and everybody does. This is the beginning. This computing platform did several things incredibly smart. Windows was not just disaggregated, as you know. Windows was properly abstracted. It was architected just right. Systems BIOSes, open chipsets, the operating system with drivers that could be connected and installed at runtime, and an abstraction layer with a multimedia API that opened up the PC to what we all know today. Each one of these elements were essential in making the PC so popular. 40 years later, Microsoft and NVIDIA are going to reinvent the PC. This is going to be the new PC. Now, tomorrow night, I think it's tomorrow night our time, but I'm going to be with Satya. We're going to talk a lot more about the work that we're doing together.
其实这个就是这一次大家非常期待的哦，他们辉达，然后跟一些合作厂商要推出，微软要推出所谓的新时代的 PC 哦。那我觉得这个新时代的 PC 最关键的就是它要能够 run 更强大的 AI 模型哦。那我觉得这个是要面对苹果的这种所谓的统一记忆体架构的一个改进。
An agent that's helping you, that understands you. You could talk to it. It could look at you. You could ask it to read files, go help you, do some research. It could do a lot more that I'll show you. But the new operating system is, of course, the old operating system plus large language models. Large language models, in a lot of ways, is the modern version of DirectX. It has, of course, input and output, understands prompts, it understands computer vision, it can generate video, it can generate sounds. It is the modern extension, the intelligence extension of the PC, of a computer. On top of that, the application, as I mentioned before, is going to be replaced by now an agentic runtime. And that is the modern application, an agent. Let's now take a look at what it can do.
It started with a spark, an idea, to reimagine the PC for the first time in 40 years, for the age of AI. What becomes of our personal computer in a world of agents? Agents running natively, connected to models, local or in the cloud. Our personal AI, sandboxed for security, running continuously, getting work done. The chips and the OS must evolve. Introducing RTX Spark, everything we've learned over 33 years distilled into one chip. Blackwell RTX GPU with 6,144 CUDA cores, 1 petaflop of AI performance. A custom 20-core Grace CPU built in partnership with MediaTek. Fused by NVLink. 128 gigabytes of unified memory. TSMC 3 nanometer process. 70 billion transistors. And in close collaboration with Microsoft, a Windows platform for agents. We're reinventing the personal computer. For creating. For gaming. For agents. This is the dawn of a new personal computing revolution. And it starts with NVIDIA RTX Spark.
Here it is. Of course, I got to show you the most beautiful part, which is video games. It's also the closest to our heart. This is Forza. This is 007, by the way. The new 007 game, I'm looking forward to playing it. I look a little bit like him. Ladies and gentlemen, NVIDIA's RTX Spark laptops. Now,
好啦，我要给大家第三个问题的一个提示啦。第三个问题的提示就是台湾 company， 台湾 company， 虾米台湾 company 呢？哦，跟这个段落有一点点关系的台湾 company 哦。那么今天
with MediaTek, I think I saw Rick earlier. This is N1X. This is a beautiful chip. This is a chip that, frankly, would take 33 years to build. And the reason for that is because 100% of NVIDIA's software stack runs here. If you want to run digital biology, no problem. If you want to do seismic processing, no problem. You want astrophysics, no problem. Everything associated with CUDA, all the physics, all the biology, all the genomics, all the AI, no problem. All the computer graphics, no problem. Every single application NVIDIA has ever created and every single application that Windows has ever run. Microsoft and NVIDIA meticulously optimized everything so that this computer literally runs everything the world has ever created, plus it now runs agents. An incredible computer. I'm so proud of it. Okay, now I want you to keep that in mind in the next video I'm going to show you. Just imagine everything here is going to run on your PC. Now that computer could have a local Nemotron 3 Ultra model or Nemotron 3 Super model, or it could have Claude Code or Codex or some other model in the cloud or something on the network, and it's going to work and do something amazing. Let's play it.
Every house starts as an idea. Getting from idea to design takes a myriad of tools, expertise, and a lot of time. Now, an agent running locally on RTX Spark can help me design a house using the tools on my laptop with an OpenShell sandbox, running the Hermes harness.
其实我觉得大家不要太在意这个 RTX Spark 可不可以玩 X86 游戏啦，我觉得应该可以玩个80%之类，它有一定的相容性啦。可是大家一定要知道，这个 RTX Spark 的这个机器是为了要跑 AI agent， 也就是说它上面是可以跑一些比较轻量级的开源的大型语言模型，可能跑个30 billion 的一个这样模型，而这样子可以让你做一个 AI agent 省很多钱，因为大家知道现在最厉害的模型都是 Cloud 云端的模型哦，但是要钱。那如果你执行比较复杂困难的任务，要花不少的 token fee。那未来你有这种新一代这种 RTX 这样的机器，它的记忆体 量够大到可以让你装一些这个轻量级的大型语言模型的时候，事实上你就会把你的工作任务分工。你一个 agentic work 里面有10个任务，有8个其实是可以用 local 端模型去跑，那就会便宜很多哦。所以我想，未来这一个电脑，这个所谓新时代的PC，
When I approve,
它是为了让你
the
跑
agent
AI
exports the
那
model from
游戏
Rhino
我
into
觉得
Blender.
效果也不会太差啦
Materials and
但是
object
我觉得也
properties
不会比
transfer
到我们
with the design context intact. I fine-tune the materials, get the look just right. Then, I pick the shots. Blender renders the house. My agent, using generative AI with the Flux 2 model, makes them photoreal. Multiple viewpoints, lighting conditions. What was once a complex workflow is now guided and simplified by my agent. Working with me on RTX Spark. Design at the speed of imagination.
PC in the world of agents. The developers are so excited about it. This is an incredible computer. All of the acceleration, all the software capabilities associated with it, working with every developer to make it incredible for all of you. The next one, Adobe. Incredible tool suite, of course, used by tens of millions of people around the world. They have re-engineered the architecture, the core of Adobe Photoshop and Premiere, and they'll release it for RTX Spark. It is twice as fast. It's already fast. Now it's going to be twice as fast. And it's also designed to be agent-friendly. With its MCP server, it can now interact with agents on your laptop. The number of customers, the number of partners that are so excited to bring RTX Spark to the market is just incredible. You know, this is the first across the lineup of PC reinvention for 40 years. And I'm just so happy that all of you and the ecosystem around the world has joined us. This is basically...
我发现大家有些人已经开始填表单了。我跟你讲，现在填的都不算哦，现在填的都不算哦。我等一下会在我答案公布之后，那个瞬间填的才算哦，好不好？所以大家不要急着先去填那个表单，好不好？哦，现在先填的全部都不算哦。等一下我会要公布题目前，我会告诉大家从什么时候的地方开始算，从第几笔记录开始算，所以现在填都不算，不要去填，好吗？
PC, and today we're announcing a whole new line. 3 revolutionary Windows machines covering desktop, laptop, and workstations. All 100% Windows compatible, 100% CUDA, 100% NVIDIA AI Tensor Core. Everything that you see that runs on NVIDIA in all these different platforms around the world runs here. This is the first completely re-engineered, reinvented line of PCs that has happened in 40 years. Now, what's really amazing is this. So this is the RTX Spark laptop. This is the desktop. So this one's from MSI. Joseph, this one's yours. Okay, look how beautiful it is. This agent could run 24/7, meter-free. And you could download your agent. You could raise your lobster in here. This is your claw. It's running all the time. No meter anxiety. And it's sitting here connected to your whole house, connected to your laptop, connected to your display, all the cameras, your dryer, your water cooler, your water heater, your everything, whatever you want. Your security system, all connected to this, and this becomes your personal AI, your personal AI agent.
先跟大家讲，大家不用先去填那个表单哦。我们的表单的到时候的顺序是我要题目公布后才算哦，所以你现在先填的全部都不算哦，哈。
And meanwhile, this is sitting at home, helping you do things. If you want to book a travel, no problem. And if you want an incredible system, this is a DGX station for Windows. Compatible with Windows, runs everything in Windows, and it has 768 gigabytes of memory. And so you could run a trillion parameter model. This is unbelievable. 20 petaflops, 8 terabytes per second of memory bandwidth, and this sits by your desk. You basically, if you're a developer of large language models, you're a developer of agents, having this sit by your desk gives you all the compute you need, and then when you deploy it, you put it into the cloud. Now, there's something that, if you look at this and think about this, something is happening here. Remember, 15, 20 years ago, we used to have an idea called a phone. Today, we have an idea called a PC. Today, when you think about your phone,
所以聊天室很多人说 Intel 完蛋了，对不对？所以你有没有突然发现一件事情？其实当时喊 Intel 要把设计跟制造拆开来的方向其实是不对的哦，因为 Intel 的 X86 注定会慢慢的越来越弱，而能够让这间公司生存的其实是它的晶圆制造生产的部分哦，所以我觉得你看，要不是 Intel 现在有个看起来已经越来越成型的 Foundry 的 business 哦，我觉得今天 Intel 之后应该不见得会大跌啦，因为我觉得现在大家看中 Intel 的也是它的 Foundry， 而不是 X86 这一块哦。
TVs, lawnmowers, dishwashers. I could totally imagine that someday there's actually an AI supercomputer in your house. And it's running all of your agents, it's running all of your assistants. And they're doing all kinds of things for you all the time. And you have to have it in your house, just like you have a home theater in your house, you have stereos in your house, you have game consoles in your house. You would have AI agent computers running in your house. And these, in time, becomes a lot more like R2-D2 to you. It becomes more like C3PO to you than it feels like a PC to you. There is no question this reinvention of the computer is as big of a deal as the reinvention of the phone into what we now know as the smartphone. And so this is the beginning of that journey. This is the beginning of a new line. And so we have a roadmap for this. This is a brand new product family for us. Every single generation of architecture, we will have a desktop, a laptop, a workstation, and then a desktop, a laptop, and workstation. And the thing that I'm just incredibly pleased, incredibly honored, is that 100% of the world's PC industry has joined us to reinvent the PC. A new line, a new beginning. Thank you.
其实昨天就有那个流出的那个联想的新的笔电的资料，所以我们其实已经大概有知道说辉达这次会发表什么了，只是总要等到他这个 keynote 讲出来嘛。
It's just a digital robot. It understands, it reasons, it plans, and it acts and uses tools. Agentic AI is going to run across all of these computers. And you've seen me talk about each and every one of these over time. We're working on humanoid robotics computers of all kinds. We're working on self-driving car computers. We're working on satellites. You have GeForce, which has tensor cores. I just talked about a whole new line of PCs. Agriculture equipment, manufacturing equipment, heavy industry equipment will all be agentic. You'll even have a little agentic helper for yourself. Even your base stations, the radio stations of the future, are going to be agentic. Understanding traffic and thinking about how to coordinate with the other base stations so that you could use as little energy as possible, increase the utilization, the efficiency of the spectral efficiency. And so everything will run agents. Today, NVIDIA is largely in the center, but I am pretty certain that there will be tens of billions, hundreds of billions over time of agentic systems, agentic computers that are going to be running around the world. The biggest problem is data. In the case of language models, all the English and all the language that we have on the internet that we trained on was from the perspective of us. We wrote it and we're reading it. However, in order to create data for AI, robotics, it has to be in the perception the perspective of the robot. And most of the world's video data is from a third person, not first person. And so agentic systems, robotic systems, physical AI, the data is the hardest problem. You've seen us move up this ladder. We started with teleoperations, which is basically human demonstration. This is no different than the big breakthrough of reinforcement learning, human feedback. Then we use simulation. This is where Omniverse comes in. This is no different than reinforcement learning, verifiable rewards, okay? And so we use these systems to bootstrap the AI model, the physical AI model. Eventually, we're able to learn from third person, reprojecting it into first person, and now, eventually, through bootstrapping, we have a world foundation model that can understand the physical world from any perspective you want. Third person, first person, outside in, inside out, doesn't matter. This is a big breakthrough indeed. And today, we are announcing Cosmos 3. Cosmos 3 is the frontier of physical AI. We are at the frontier with language models. There are so many people working on it. However, in physical AI, we are absolutely the world's best. I am so proud of the team for doing this. This is the foundation model for all of your work. Whenever you want to create a robot, whenever you want to create a factory robot or a robot that works in a factory, any kind of robot that involves physical world, you now have a companion, a Cosmos 3 that can understand and reason. It can generate. It can simulate in the loop. It can even be the policy itself. It is on the top of leaderboards all over the world. I am incredibly proud of Cosmos, and today we're announcing Cosmos 3. Let's take a look.
The real world is infinite and unpredictable. Physical AI needs data, but real-world data is impossible to scale. For physical AI, compute is data. This is Cosmos, an open frontier omni-model for physical AI, built on a new mixture of transformers architecture. Pixels, action, sound, and language flow into the autoregressive transformer, which reasons, plans, and instructs the diffusion transformer, which generates what comes next. Developers post-train Cosmos across embodiments and use cases. As a VLM, Cosmos watches the physical world, understands what's happening, describing scenes, and flagging what matters. As a world model, Cosmos generates physics-accurate synthetic video from an image, text, or video. As a simulator, Cosmos closes the loop for policy training and evaluation. And as the foundation of NVIDIA OmniDreams, an action-conditioned world model, Cosmos predicts the future frame by frame. Post-train Cosmos, and it becomes a world action model. Perceiving, reasoning, planning, generating actions. For robots of every kind. For everything that moves. A new kind of data, a new kind of teacher generated by compute. Cosmos, the foundation for developers of the age of physical AI.
我看聊天室不少人在聊这个记忆体未来会很贵哦。这个我在节目已经跟大家讲过一两次了吧，就讲说我觉得虽然我不是什么记忆体专家啦，但是目前以我自己抓的模型估算，未来10年记忆体都不太可能出现供过于求的一个状况。
AI, compute is data. And so use Cosmos 3, train a whole bunch of AI models. Cosmos is such an incredible open model system. It's exactly the same as Nemotron. We open the model, we open the data, and we even opened how we trained it so that you could enhance it for yourself and turn Cosmos into your proprietary model. We have such incredible partners working with us in so many different industries. Now, the model itself is the most understandable part of the AI stack, but the AI stack is very complicated. It has generators, the model, simulators, and the runtime. Just as it is for agentic systems, these cars, or essentially a physical AI, a agentic robot that is a autonomous vehicle, has also this complicated stack. Today, we're announcing Alpamayo 2, an open model for self-driving cars. We're working with car companies across the world. If you look at these brands that have signed up for the NVIDIA Hyperion, that are building NVIDIA Hyperion cars, this represents about 80% of the world's cars. The manufacturers represent 80% of the world's cars. We are going to have a whole lot of NVIDIA Hyperion systems that are able to run Alpamayo or anybody else's AV stack. We are also connected into mobility services. Approximately 97% of the world's mobility services are connecting with us so that when we deploy Alpamayo on the Hyperion runtime with the Halos operating system, we will be able to connect to all of these services across the world. Let's take a look at this.
好了，我再补充一下那个记忆体的那个部分哦。我讲的那个未来10年都不会出现供过于求，是指目前各大厂的增产计划。哦，那目前主要的几个记忆体厂，他们现在预计的增产计划大概都是未来几年大概 maybe 增产个1-2倍这样子的概念哦。但是我猜啦，我猜几年后，说不定会有厂商说，我一口气要增产5倍、10倍。那个时候可能就不一样了，供需就不一样。但我们目前没有看到主要记忆体厂的计划，哦，没有看到他们的增产计划都有，可是没有到非常夸张，所以目前的状况是这样子。哦。
Cross traffic, since the vehicle is crossing ahead. Keep distance to the lead vehicle. Nudge left due to the truck blocking the right side of our lane. Nudge right due to the truck blocking the left side of our lane. Nudge left due to the truck blocking the right side of our lane. Your destination is on the right.
Alpamayo, the world's first reasoning autonomous vehicle. If you let it talk all the time, it will drive you crazy. But we're very happy that it's talking to itself all the time. That's called thinking. And so Alpamayo is a reasoning car. The technology that we've created also applies to humanoids. Of course, there are many new breakthroughs that has to happen. The NVIDIA Isaac GR00T is our humanoid robotic stack. Model, data generation, simulation, the runtime, including the operating system. This represents GR00T platform, the Isaac GR00T platform. Every one of our systems, as you can see, the exact same pattern, whether it's agentic system for the cloud, agentic system for the PC, a robotic system for a self-driving car, a robotic system for a human or robot, all the same. And of course, in every single case, we build everything completely. We build everything vertically, completely, integrated with co-design, extreme co-design, and then we open it up for everybody to use whichever part you like. And whatever you want to use, we even help you modify. But the one thing that is missing is we need a reference platform for robotic systems. These robotic systems are so complicated, so many motors, so many sensors, so fragile, and yet we need to have a way to deliver these reference platforms just like we do with PCs and DGXs and clouds and self-driving cars. We now are going to do it for robots. Today, we're announcing the NVIDIA Isaac GR00T, a reference humanoid robot, all fully integrated. 25 degrees of freedom on each hand, made by Sharpa. 31 degrees of freedom on the robot, 6 feet, 150 pounds, just like me. The first number is shorter, the second number is bigger. Otherwise, pretty close. And this platform runs the new Thor and our entire software stack. Data generation stack, data simulation stack, the runtime, all integrated into a robot that is designed for everyone to use. Now, we built this for higher education and university researchers because for them to build this is insanely hard to do. And so let's take a look at that.
The next leap in AI is general-purpose robots, humanoids. But building one is hard. Every team starts from scratch, stitching together simulators, teleop systems, data pipelines, and training infrastructure. Months of setup before research can start. NVIDIA Isaac GR00T, an open development platform for humanoid robots. Open models, simulation and training libraries, and data generators. Plus, the robot computer. Fully pipe clean, ready to go in hours. First, set up the simulation environment in Isaac Lab. Capture demonstrations with Isaac Teleop on a real or simulated robot. Generate synthetic data with Omniverse and Cosmos, scaling one demonstration into thousands. Train policies, evaluate them in Isaac Lab Arena. Deploy through Isaac Ross, running on Jetson Thor. Every element, modular, open. Use ours or swap in your own. GR00T is powering robotics research across every discipline, for every domain, from research labs to factory floors. One open platform. And now, a new addition. Isaac GR00T reference design robots. Built on NVIDIA's open platform. Ready for frontier research, for any lab, anywhere. The age of robotics starts here. NVIDIA Isaac GR00T.
So many robots. We're working with just about everybody who's working on robots in the world, or robotic systems in the world. Let me tell you what I told you. The computer industry has been completely changed. In the last 6 months, everything changed. Everything changed because agents were realized, and it converged with the latest frontier models, and it made possible the AI to now do useful work. The computing pattern will repeat over and over and over again. This computing pattern of an agent that's a model, a harness that uses tools with skills and runs in a runtime. That runtime depends on whether it's in the cloud or on-prem, on a PC, or in a robot. But the computing pattern is exactly the same for all of them. You will use different harnesses because of your preference. You'll use different models because of your preference.
聊天室有人问说：“那是不是以为这场 keynote 只有1个小时？我本来以为大概是1个小时多一些些啦。所以的确，我本来想说，通常他黄轩演讲通常都是1个小时20分钟到1个小时40分钟居多啦。
Engage AIs, and for us, it's a wonderful growth opportunity. Vera Rubin is in full production, whereas Grace Blackwell was created to process AI, particularly inference. Vera Rubin was created to run agents. It is in full production. It is much, much more than a GPU. It is in.
好了，现在要总结了，所以应该快要结束了，快要结束了。
NVIDIA has really become an infrastructure company, not just a GPU company, not just a systems company, but an infrastructure company to help you generate the maximum revenues, the maximum profit, and to get there as soon as possible. The agent world, this new way of doing computing, where you build CPUs now for agents, not for people. CPUs for agents has its own special requirement, and our NVIDIA Vera is revolutionary. I'm so happy about its ramp. The orders already is going to make it the fastest and the most successful product launch in our company's history. NVIDIA and Microsoft has created a whole new line of PCs. This is a new beginning. And of course, that exact same agentic processing pattern, computing pattern that I just described is also going to run on all kinds of devices. I mentioned PCs, but in the future, it'll be robots and satellites and base stations and factories in the cloud, on-prem, at the edge. This pattern, agentic AI system, this agentic computing pattern will be replicated in computers all over. How we think about the personal computer will very likely change. I want to thank all of you for your partnership, your friendship. We couldn't be here without everything that we do together. I am so proud of how you've been so successful this last year. The next year is going to be even more. I have one more thing for you. Let's take a look.
他要秀那个，我不知道他是不是要秀那个台湾最新的总部的设计哦，因为他们有说他们那个台湾的总部要设计有改哦，改成一个全新的一个设计。
You ready, Taiwan? Let's do this.
The keynote's done at Computex. Jensen showed the world what's next. Useful AI has arrived. Agents working by your side. But in case you missed things we said today, we're gonna break it all down for you, Taipei.
Agents used to be misunderstood. Only movie stars had them in Hollywood. Now we all got teams making dreams come true. Building companies from living rooms. But they need so much compute, we hear ya.
That's why we created Vera. Ruben stole the show, it's true. The cheapest tokens coming through.
10 times faster inference heaven. More special agents than 007.
Bluefield keeps agents' memory true.
Now, let's talk about its CPU.
50% faster, that's outrageous.
Not for Vera.
It's built for agents. NVLink Fusion blends A6 smartly.
Everyone's welcome to the NVLink party.
Well, if you like that introduction,
Vera Rubin's in full production. Nemotron Ultra leads the run. 5x faster work gets done. Nemo Claw keeps the guardrails right. Open Shell keeps the sandbox tight.
your code migrated and reviewed.
All before this song is through.
AI is a 5-layer cake. Computes revenue. Make no mistake.
Global AI clouds build lots of gigawatts. DSX keeps power lean, connecting dots.
Every watt optimized for you.
So you can have your cake.
Can eat it too.
RTX Smart is finally here.
Biggest PC moment in
40 years. Agents powering all workflows. Running anywhere Windows go.
harnesses run on CPU.
Models fly on GPU.
Cosmos builds worlds that robots need.
Turning compute into synthetic feed.
Output my OCs and reasons through.
Understands roads like people do.
Who is how they learn to move.
Learning skills and finding grooves.
Geometries powered by Thor.
The future's humanoid. Count on The future's bright. Come see what's next.
Thank you, Taiwan.
Welcome to Computex.
大家谢谢。Computex, 大家谢谢. Thanks for an amazing year. Thank you for all your friendship and support. Thank you. Take care. Have a great Computex.
哦，他最后这个歌 MV 歌蛮厉害的哦，蛮好听的呢，蛮好听的哈。这个，然后我觉得他也顺便做个人情啦，因为他台下这些合作厂商，每一家厂商都在 Computex 都有很多的这个表演嘛，就是有很多重点嘛，这些台湾这些厂商，所以他就来宣传一下 Computex， 哇，这个人情做到饱，人情做到满哦。那我们也知道说，哇，我觉得台北市真的，我们刚刚聊天室有说万安啊，把这个影片授权一下，哎，这个东西做台北的这个东西做台北的城市秀应该算不错啦，对不对？算是还不错啦，哈。好啦，那随着时间过去，我们Jensen的演讲也正式结束了，对不对？ 那我们就准备要进入我们的这个抽奖时间了哈。我就跟他讲啊，先答题的都不算好吗？哦，你们也不一定有真的猜对我们题目是什么，好不好？哦，那个，哦，所以来哦，所以先不要急着答题，先不要急着答题。我先把我们的这个视窗投影出来，把我们视窗投影出来啊，这个投影。这个视窗，这个，好，大家可以看到，对，这个是我们的视窗啊。我们现在呢，回答是到第52个，到第52个啊，到第52个啊。所以我们等一下公布题目之后，前52个都不算了，我们要从第53个开始算了哈。那最后给大家提示，给大家3个，大家记不记得提示是什么？第一个提示是什么？第一个问题的提示是什么？第一个问题的提示是什么？第一个问题的提示是，第一个问题提示是什么？大家记得吗？大家记得第一个问题的提示是什么吗？什么利比利啊？大家觉得是什么东西啊？什么东西啊？我们第一个问题的提示是 LPU， 对不对？那我们第二个问题的提示是什么？第二个问题的提示是什么？第二个问题大家记得提示是什么？第二个问题的提示是 model， 第三个问题的提示是台湾公司哦。那我们即将要公布我们真正的题目咯哦，大家可以在画面上看到，现在已经有人把这个，现在已经有人把题目填到69哦哦，我们等下公布的时候前69个都不算哦，前69个都不算哦。哦，前69个都不算哦，好，前69个已经有73了，前73个都不算哦。哦，前75个都不算哦，现在不要去填，现在不要去填哈，你们先填的都不算哦哈，先填的都不算哦哈。好了，我们要正式公布题目咯。啊，题目，来，我来抓一下题目。好，我现在要截止哦，截止前78个都不算哦，前78个现在不要填哦，现在填的都不会算哦，不要再算哦，等我说开始之后才会算哦。现在这个数字停留在78，停留在78。好，题目要正式公布了，题目要正式公布了，3、2、1，题目公布了，题目公布了，来，问题完整版，赶快抢答。有一个人答对了，第81个答对了。好，那我们前几名已经出来了，我们来看这个我们的荧幕好不好？前几名已经出来了哈。来，第一个哈，你答案第一题的正确答案是 Grok， 第一个正确答案是 Grok， 不是 Grok 3。我们第一题是什么？你并购哪一间公司哦？哈，并购哪一间公司哦？所以是公司名称，不是晶片名称哦，哈。所以第一个问题的正确答案是 Grok，G-R-O-Q。第二个问题呢是回答自己开发的模型是什么啊？这一题你不管是打 Nemotron 3、Nemotron Ultra 都算你对啊，因为叫 Nemotron。好， 第3个呢是辉达最新公布的 RTX Spark 是跟台湾哪一家公司共同开发？当然就是我们的联发科哈。那我们刚刚是最后一个回答，是从79之后开始算的，所以我们现在把这个来把这个投影出来，我们来看看谁答对哈。来放大一点，放大一点，放大一点哈。所以来这里第81名啊，克林台包好吃，恭喜你是第一个答对的，所以是克林台包好吃哦。啊，第二个第二个答对在这边哈 ，Alan 哈 ，Alan 你答对了哈。第3个是什么？哦，这个 Never S0 哈 ，Never S0 哈，所以你看，就叫你们不要乱猜题目嘛啊，什么 Grok 3没有啦，你多个3你就没有，你就不能答了啦哈。哦，所以啊，我们等一下来抽这3个人哦，看这3个人谁抽中，好不好？我们看这3个人谁抽中。啊，来，然后我们今天啊，所以我们这时候要叫出我们的什么？我们的这个轮盘啊，叫做我们的轮盘啊，叫做我们的轮盘。我们的轮盘呢，我的轮盘啊，恭喜这3位你们有机会啦。好，第一位我们要刚刚说第一位是克林台包，对不对？克林台包，哎，这个人他怎么知道我喜欢吃克林台包？哦，这个如果是老观众才知道克林台包啊。好，第二位是 Alan 哦 Alan。啊，第三位是 NEVERS0，来，恭喜你们3位，其中1位会获得啊，另外2位就没有哈，没有办法。NEVERS0哈，这3位哈，来，我们来看看这3位谁会赢，我们来看这3位谁会赢，来按一下旋转，按一下旋转。看谁要赢啊！恭喜你们3位，我自己都没有办法获得这一个，我自己都没办法获得这一个哦。克林台包的包子跟水晶饺都很好吃哦，老观众才知道我喜欢哈。好，来，我们要转了，我们看谁会赢呢？3、2、1，转了，看谁要赢，谁要赢，哇！我们恭喜克林台包哦，他也是第一个答对的啊！哇，恭喜克林台包这个获得我们今天这个 NVIDIA 送的4080黄仁勋的签名版哦！哦，恭喜克林台包哦！然后这个我们辉达会联络你哦，因为你有留你的手机、你的电话，所以辉达会联络你哦，就是这样子，不是我送啊，是辉达送你了，好不好？好啦，那我们恭喜克林台包哈。那如果喜欢去台南，真的可以去买克林台包的这个包子跟水晶饺哦。那你也知道，台南的水晶饺跟我们一般你想象中的水晶饺不一样哦，哈，这跟你一般想象中的水晶饺是不一样的东西哈，你知道吧？所以很好吃啊。克林台包我也很喜欢，哦。就是我最早喜欢吃的是那个花莲的公正包子，但后来公正包子不太行了，直到我吃到克林台包之后，才终于台湾又有一个我真的很喜欢吃的包子。好了，那今天我们的 Watch Party 就到这边了，那谢谢大家线上观看。那今天台股应该也涨了，那接下来就让我们一起在 AI 的大潮一起生存下去了吧。那大家拜拜。